So I hope you guys have downloaded this book. I encourage you to, sort of at least skim through it with me. We have finished chapter 4. We're going to focus on 5, 6, and 8. We're going to skip 7 because 7 is somewhat detailed for data science oriented skill sets. So person detection, and again, you can go onto that platform that I showed you before. Again, go into the playground, and then you would see something similar. This is Visual Wakeword, and you can, create your application here. This is all no-code applications. We are going to add more as and when the time comes, and you can build your own and add application here. So there is another way that you can sort of give us your ideas onto this platform. This platform is free. We are not charging anyone for this platform. So this is Visual Wakeword detection, where you can sort of create this application. For example, you want to create a doorbell like Ring or Google Nest, and it opens the door when it sees you with facial recognition. In this case, we're going to talk about person detection, meaning it looks at the frame and sees if there is a person, and then, for example, it alerts you, right? I have a door which is a Ring doorbell at my home, and whenever Amazon is delivering, it actually tells me there is somebody on the door, and I see it on my phone, on my TV, on my other screens that are throughout my house. You can ask your smart speaker to stream the video that is captured by the doorbell, right? So how does the doorbell know if there is a person, right? That's the algorithm. The algorithm that we're going to talk about is essentially what it uses. A variation of that is used to detect a person. And why it is important, especially for the doorbells that are not connected with electricity, the battery is very important, and you want your hardware to sleep most of the time, meaning sleep as in like it's not using any of your battery. Otherwise, battery runs out in few hours to few days. For example, your cell phone needs to be recharged every 8 to 24 hours. You don't want other appliances to be charged like that. And that goes for the usability, right? So I'm not going to take you on that platform. I urge you to go on, sign up. But this is how it works. You record yourself for about 2 minutes, and with you in the frame, and then the other data set without you in the frame. When you have these two frames and you hit train, it creates the model. The next screen will show you, and you can capture yourself to identify if there is a person in the frame or not, and then download the application the way we did for our audio use case, right? That's the vision use case that we're talking about. And before we move on to the fourth application, let me give you a fun fact. If it was a live audience, it would be fun to have the quiz, but the fun fact here is the number of sensors today in the world is about 1 trillion. And it is expected to grow by 2032. There is a research study that's done that in the next 10 years, it will be about 50 trillion. So it's going to grow from now to the next decade at a phenomenal rate to give you over 50 times growth on the number of sensors that you will see in the world today. And 10 years from now, when you have those many sensors, there would be flood of these TinyML applications in the next 10 years. So if you're in the first year, second year, or third year, you might want to start learning about some of these. And some of you who are planning to do your PhD, it takes about 10 years from your first year BTech by the time you're done doing your PhD. So the field would be right about ripe. And there would be practically every company that would be looking for skill sets like embedded engineer, your data scientists, and some of these sensors engineers and such. So do pay attention.